Okay. All right, we should be live. And am I hearing audio? I am hearing audio, and I am getting noise canceling. Good. Okay, so just my watch telling me we've gone live. So I'm going to refactor the recursion for prime factors to I think I'm going to do it. I'm going to optimize it, hoping that I can find the solution. Because right now it takes too long. It doesn't actually get to the solution. So we never found the actual answer, right? So let's work on that. So let's open up our tests. Recursion prime factors. We don't know what this one is equal to. So I think what I want to do first, no, I don't want this one. Recursion. So here we go. What I think we want to do is switch the order. So once we find, if we work backwards, once we find any prime factors, we know that's the largest, right? So instead of doing input number and starting at 1 with the candidate and working our way up, what if we start at input number divided by 2 rounded up and do -1 for our candidates, right? So So we need to refactor, let's refactor calculate factors, and then we'll use that to refactor calculate prime factors. So, so if our input number is our number we care about, our candidate is going to be um, input number -1 to start with, and our or input number divided by 2 rounded up, because we know that the factor is never going to be larger than, unless the value itself is prime. The factors are never going to, the factors that we care about are never going to be larger than the input number divided by 2 rounded up. So, and then our results is going to be an array. And actually results, let's make results just be, okay, we still need calculate factors here. This actually is fine. What we need to do is switch it here, right? So if candidate, let's switch this. So we're going to make results be a number, or let's just do this. Oh, that won't work because it's still sum of the prime factors, right? Is there a largest? So calculate prime factors. Let me go look at the problem. Let's do this. I'm gonna switch over to Chrome. Let's add a new capture. We'll call this Chrome. Application capture, Google Chrome. Okay. All right, we got Chrome. Let me move my little video back to the front. Move up. Cool. All right, so projecteuler.net. I was sitting there working, I was actually cooking dinner, It is. It's largest prime factor. It isn't sum of prime factors. It's what is the largest prime factor. So we don't actually need to sum them all. So if I go back to um, order move up, there we go. Go back to Visual Studio Code. And we don't need all of the prime factors. We just need largest prime factor. So that's going to be a number or null, and the result is just going to be a number. And we, instead of calculate prime factors, we want to do calculate largest prime factor, right? Calculate largest prime factor. We're going to end up refactoring this anyway, so let's just do this. So, okay, so if results equals null, then we're going to recurse, right? We're going to actually, we can't just do that. We have to say if results does not equal null, right? If results does not equal null, if it results equals null, then do that, else return results. We'll recurse one extra time. That's fine. So if results equals null, then we're going to say if is prime candidate then calculate largest factor, input number, candidate, results will be candidate, right? And then we have a candidate. We have a results. That is a number, right? Else, calculate largest prime factor, input number, candidate -1, results. If results equals null, okay, so what's this say? Expecting expression equal null when it is replaced with default expression. Okay. If using if oh. In this case, I actually, okay, is empty if is empty results. Um, and we'll just do this. Number or we'll just do this. We'll just make this a number, and we'll just make sure it gets called with results set to 0, right? So if results equals 0. The only problem with that is in theory, we could create an infinite loop. I don't like that. I'm going to delete that too. We don't need the sum of the prime factors. But we'll come back to that. So calculate largest prime factor. Candidate. Let's leave that as empty. We don't care about that. Let's say 0. Uh-huh. And we'll do that. If candidate does not equal 0, right? If candidate does not equal 0, yeah, we'll do that. So if candidate does not equal 0, if it's prime, calculate the largest prime factor. If it and return the candidate, set the candidate to 0. That'll break out of the loop and return the results. If it's not prime, then we calculate the largest prime factor, subtract 1 from candidate, and do results. Okay, cool. I think that's going to work. So we don't need this at all. I don't know why we have sum of prime factors here. Let's just delete that. Calculate prime factors. So that's wrong. We don't need sum of prime factors at all. So we want calculate largest prime factor of 35. And then let's see, 35 divided by 2. And then ceiling. Yep. And then this is going to be 0. And then this should now equal to 7. Right? And then this is going to be ceil 13195 divided by 2. And we'll set this to 0. And we now want this to be 29, right? So let's see if we run those two tests, that should fix any, that should optimize our code a lot. Now we still have the problem of we're iterating through the calculate factors. I don't have a good solution for that other than, we have a bad test. To be 7, but was 17. Oh, I'm just getting prime numbers that's in there. We also need it to be and is a factor, right? And input number mod candidate equals 0, right? So let's wrap that. Okay, that's easy enough. So if it's prime and input mod candidate equals 0, actually, I don't want to calculate is prime unless this is the case, because we only want this to hit. We don't want the computationally intensive one to happen until we know this is the case. So let's do this. So let's make this a top level. I hate nesting if statements like this, but we're gonna do it. So input number, if input number mod candidate equals 0, then we're going to I guess we could add an and statement. Then is it only going to execute the and is it only going to execute the computationally intensive if this one already is evaluated to true? Let's just be extra safe. If is prime candidate, then we'll do this, right? Else we're going to do the same thing we're doing here, right? Okay, so let's do that. That should get us now. That doesn't just check if it's prime, it also makes sure that it's a factor. Before, right? Yep. Mod can equals 0. So we even need this at this point. So we need to know if it's prime or not, right? So yeah, we still need the computationally intensive. We'll look at that in a little bit. Let's run this first. Sorry about the background noise. I got folks coming home from work and all that fun stuff. Something's going on with my console here. It's spacing between all of my. That's weird. But we got green tests, so that's cool. All right, so let's see. I'm gonna close this and reopen it. Maybe that'll fix the console. Will that fix my console? I don't like for some reason it's adding spaces between every character. Yeah, it's still doing it. All right, well that's a weirdness of Visual Studio Code. Does that every once in a while. It did it to me earlier today too. All right, cool. So let's see. So I don't think we can calculate our solution yet, but if we try to run it for a few minutes, maybe we'll get something. It should calculate the prime factor, the largest. This needs to be the largest prime factor of 35 as 7 and of this as 29, right? And should calculate the largest. Can I talk to you for a second? I am. Okay. um, Sorry, I got to do honeydews this evening. Of So what is our largest prime factor supposed to be? Of 608. Yeah, I think we have it in our tests down here somewhere. We delete it? We did delete it. Let's go look in our other prime factors test suite here. Yep, here it is. This value. So it'll be this and do, all right. Calculate largest prime factor. That ceiling is going to be that divided by 2 and 0 and must equal to 0. Now, this might run for a week. It might run for a minute. I have no idea. So we're going to kick it off. While it's running, we're going to see if there's any while it's running, we're going to see if there's any other refactoring we could do for optimization. Okay, so let's kick it off. Still don't know why it's inserting all of the spacing, all of my. Okay. All right, it's cranking away. While it cranks away, let's see if we can optimize this any. So we definitely can, because we can go down instead of up and throw away, do the same ceiling thing we're doing here, right? We can say, and results is, we can set our results to be the target value, right? So is prime candidate. Yeah, so we can do that. So it would be, we need to refactor the interface for calculate factors to be just like before. Well, it's still going to be an array of numbers, and it's still going to return an array of numbers. But now the array of numbers is going to be reversed. It's going to go from largest to smallest. And we're going to automatically put in our top level number, right? Because we know that's right. So, okay, now I'm curious. So let me move, well, this is running, it's still cranking away. Let's move Chrome up, and I want to check something. So Chrome, so data weave, so 20, so 15 mod 1 is 0. Yeah, of course, duh. Okay, so that's going to work fine. So let's order this back up to the front. Okay. And still cranking away. Just let it crank away. It's not hurting anything. We're going to optimize. So we need to refactor it to be similar to this, but instead it's still going to build a collection, right? But we're going to go down, and we're going to throw away the first half. So that's going to drastically speed up things. And we're going to throw away even numbers. Let's do that. We'll throw away even numbers. So we'll do -2, right? Divided by 2, round it up. -2. minus 2. Um, should we have gone minus 2 here? That would definitely throw away half of our can. We'll think about that in a little bit. Um, okay, so let's just one optimization at a time. Let's change our interface. We're going to keep this. We're actually going to keep the interface, but we're going to change what we do. So we'll do this. So if candidate does not equal 0, then if input number mod candidate equals 0. Yep, we're doing the same optimization there. And then if we don't need to do the is prime there. We would just do calculate factors, right? Input number candidate minus 1 results. No, it's going to be results, and we're going to append on candidate, right? There we go. And then else calculate factors, input number, candidate minus 1, results, and then else results. Okay. I think that'll give us calculating the factors, and we're going to go down, which is fine. We can just reverse our list, right? Just reverse it. Well, we don't even care about that because we're just doing size of right there, right? So, and we can just reverse our results here. Reverse results. There we go. Is that a data weave array? I think it is. So, port reverse from DW core arrays. Oh, it's not, they don't give us a reverse function. We can just do this. Results. -1 to 0. All right. I'm having a brain fart. It's late in the day. I'm having brain fart. So we're gonna do this. I'm gonna switch this back over to Chrome. Just look real quick. So we've got 1, 2, 3. Actually, let's make sure it's something other than just sequential numbers, right? 0 to -1. 1, 2, 3, 4, 5. Oh, -1 to 0. Yeah, -1 to 0. -1 to 0. 5, 3, 2, 1. Yep. Okay. Yeah, that's it. All right. That's what I thought. I don't know why I'm having a. We all forget how to do stuff sometimes, right? Okay. Yeah. So -1 to 0. That reverses our factors. at the end. And so now we're going to call candidate ceiling candidate divided by 2 and then candidate, right? That should work. And that should throw away a lot of numbers. So let's stop this. Let's go comment out this test. And then let's run our test suite and make sure, see if our refactor worked. That should, in theory, significantly optimize our code. Should calculate expecting root to be array size is. Okay, I need to close this and reopen. I'm going to close and reopen Code Studio, Visual Studio Code, because it is acting wonky. Close it. And Visual Studio Code. And if I run my test now, let's see what we get. I mean, restarting Anypoint Studio is like a regular occurrence for me, so. Let's see, test results. Okay, that fixed the issue. And we have green tests. Interesting. Something was weird with Visual Studio Code. So we didn't lose our changes, did we? No. And our codes and our tests are still passing. So let's just sanity test check. We're going to run it one more time because we were expecting them to pass and then they failed, and then I restarted the IDE and they worked. So that worries me. Okay. We're going to throw away this. Oh, wait. This is not my recursion test. That's why. Recursion prime factors. Recursion prime factors. All right. I think I was running the wrong test suite. That's why. Okay. So I'm expecting this to fail. We'll figure out why. Yeah. A size to be 3, but it was 1. Should calculate the factors of 5 as 1, 5 and 1. Should calculate the factors. But array size. So we're only getting we're not adding. So if input number mod candidate equals 0, results candidate minus 1. If candidate does not equal 0, candidate minus 1, results -1 to 0. So why is this not working? So calculate the factors of 1, 3, 9. So let's comment on all these other tests. And K, Command C. Is prime is still working. Command K, Command C. We are going to comment on everything but one test. We're just going to focus on one test. Command K, Command C. Run that one test. And my watch wants me to go for a walk. I am not going for a walk right now. Busy. I've had dinner, which was an omelet. I've walked the dogs. I want to get this figured out. All right, so let's add a logger here. Um, if log candidate is not equal 0, actually, I'm gonna log here because we want to see if we go into input number mod candidate. I think I might have screwed something up in here. So we're gonna log candidate right here, right? And see if we ever get inside of this. Let's see. And we're starting with, oh, of course, we wrote our tests wrong, right? We need to, um, yes, of course. So calculate factors, we need to write it like this, right? So it's going to be 9 ceiling. Yeah, if we go 1, oh, that's the issue. We have 1 and it's just going down. Of course. So if we did this, if we just change this to 9, this would pass, right? We changed what we mean by candidate. I changed the I changed my interface out from under me and didn't realize it. Yeah, that was it. Of course. So we're going to turn off the log right here, right? And we're going to uncomment these. Let's just uncomment everything. So okay, comment. And we gotta fix these. So this is gonna be 5. This is gonna be 12, and this is gonna be 1. 1. 1. Greater equals 0. Yep, yep, yep. That's all fine. That should all be fine. Yep. And then okay, save. That's the issue. I just changed my interface and didn't. I broke my own function interface. Didn't catch that I had done so. This should just work now. Oh, yeah, I uncommented the really big one. Let's stop it. We're going to comment back out this one just to make sure all of our tests are good, right? Oops. What did I just do? Opened a diff or something. There we go. Still learning all of my shortcuts on the Visual Studio Code, and sometimes I do the wrong one. All right. Let's uncomment this one. Run these. Make sure our full test suite's working. And then if it's working, I'm going to kick off the run, stop the stream, and and I'm gonna let it run. Just gonna let it sit there and recurse because it should never hit a Stack Overflow. And gonna let it run, and we'll see in the morning when I start the next stream what we think if I ever got the result. But I think we're optimized using this recursive approach. I think we're as optimized as we're going to get. Um, like this is clearly not the right approach. I don't think DataWeave is the right tool. But honestly, without writing this in like C or something, or going and digging into uh, factoring algorithms, which I'm not going to do, I think this is our best chance at getting an answer. So, um, yeah, we're gonna let's comment out everything but that test. Save our changes, run our test suite, and that's gonna end our stream. And I'll let folks know in the morning what the answer, if we get it, is.